everyone, we're going to state the number of positive real solutions, negative real zeros, and imaginary zeros for each function. We're using Descartes' rule of signs, and here is our function. Now, Descartes' rule of signs is basically only for the reals. So basically for the imaginary zeros, we can infer that from our reals. According to this, we're going to look for the positive reals first. So we want positive real zeros. And what you do is you could evaluate f of 1 and just write out all the coefficients. So if I plug in 1 and all that, you're going to get 1, negative 1, 1, 1. So many ones, I'm getting confused. All right. We have 5. Okay, so, and you look at the sign changes. From 1 to negative 1, that's a sign change. From negative 1 to 1, that's a sign change. From 1 to 1, that's not a sign change. And from 1 to negative 7, that is a sign change. So we have 3 yeses. That means 3 sign changes, or it is less than this by an even number, so 3 or 1. Now for negative real zeros, you do the same thing basically, but instead of evaluating f of 1, you evaluate f of negative 1. And basically what you're doing is the number's going to change for your odd powers. So anything with the odds, so if you have negative 1 cubed, that's going to be negative 1. But if you have negative 1 squared, that's going to be positive 1. So basically all you're going to do is, on the odd power ones, 1, 2, and 3, change the sign. So this is going to be negative 1, and we still have negative 1 for this one. And then for the cube, it's going to go to negative 1. And then for this, it's going to go to negative 1. And so we still have our negative 7. And if you look at this, none of the signs are changing. So if you do like we did before, all of these would be no, 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 no. No sign changes, so 0 negative real solutions. Now, from here, we can look for our imaginaries. So for our imaginaries, we can have a total of 5 solutions, or zeros. If we have 3 positive reals and 0 negative reals, then that leaves us with 2 imaginaries. If we have 1 positive real and 0 negative, that leaves us with 4. So it's going to be 2 or 4. There should be ors here. All right, and that's how you can infer the imaginary zeros. And remember, the imaginary zeros come in pairs. So, for example, if you have 3i, then negative 3i is also a solution. Or 1 plus I is a solution, then also 1 minus I. So there always has to be an even number of imaginary zeros. And that's it. Thank you. Have a nice day. Bye-bye.